Welcome to our fourth experiment, which is all about communication. We are now able to communicate with anyone across the world, anywhere, from the palm of our hand. But did you know that until around 30 years ago, people didn't really use mobile phones? You used to have to ring your friends from your home phone or from those old red telephone boxes. Imagine not being able to FaceTime your friends or talk over Zoom. Communication technology has been improving at a lightning pace, and it creates billions, even trillions, which can be used to fund lots of research in this area. Just look at the way phones have changed over the years, from a Nokia 3310 to an iPhone 12. Now, phones are more like mini computers to not only communicate, but to play games, pay bills, watch movies, read books, and much more. In order to try to understand how we communicate, we need to understand sound. Sounds are all around us. Cars honking, phones ringing, friends talking, and dogs barking are all sounds you're probably familiar with. But what is sound? Well, sound is a type of energy that causes vibrations. When any object vibrates, it causes movement in the air particles around it. These particles bump into other air particles close to them, which makes them vibrate too, causing them to bump into other air particles. We call this movement sound waves. The waves spread outwards from the vibrating object, a bit like the ripples when you drop a stone into water. Some of the best communicators in the world are dolphins. So let's watch this short clip about how dolphins communicate.
Sorry.
Hi! How about that? See, they're talking to you.
How cute she was.
Moving on to our first questions. Which organs do we use to detect sounds? Of course, that's our ears. Is there any sound in space? No. Can you explain why not? Well, there's no air in space, so the sound has nothing to travel through. And what's the speed of sound in miles an hour? Well, that is a hard question. It's actually a very fast 761 miles an hour, which is much faster than your car or any other car for that matter. Moving on to our experiment for today. Let's get our equipment ready. We'll need paper or plastic cups. You can use tin cans, but you'd need to be extremely careful with sharp edges. String, a nail, and paper clips. You'll need a line of string for each communication device. Around 3 meters is ideal. Carefully use a nail to create a hole in the bottom of each cup. Then put each end of the string through a hole in a cup and tie a few knots, or use a paper clip so that the string doesn't fall out. Each person take one cup and stand away from each other so that the string is taut. Then speak to each other through the cups. Hello? Hello? Hi there, who's that? It's me. Oh, of course. Experiment with your string telephone by gently pulling the string taut and then letting it fall loose. Pause the video, have a go, try this experiment, and when you're ready to discuss the results and further questions, press play. Now, let's talk about which works better, taut or loose string. Taut works best. When the string is loose, it's softer than when it's taut. Soft materials tend to absorb more sound than solid ones. When more sound is being absorbed, your friend on the other end of the line can't hear as well. What happens when the vibrations, or sound waves, reach the other end of the cup? It's the reverse at what happened on the first end. The waves in the string vibrate the cup. The vibrations from the cup disturb the air like a pebble being thrown into water. And the vibrations in the air, otherwise known as sound waves, travel towards our ears. Try changing the length of the string. Do sounds get louder or quieter? You should notice a difference, since sound waves lose strength with a greater distance apart. Engineers have helped sound travel great distances by designing devices that convert the sound waves into electricity and back. What other things could you use as your earpieces? We discussed paper, plastic or metal cups, but what about wood or using a seashell? Have you ever been to the beach and listened into a seashell? If not, have a go. When you listen to a shell, you're not really hearing the sound of the ocean. The shape of a seashell just happens to make it a good amplifier of the noise around you. It makes it louder. That's the end of our experiment today. Join us again tomorrow for the 5th and final experiment. We're going to be focusing on the innovation of medicine. See you soon.